Number 15, we want to determine the implied domain. So if we refer to the examples from earlier, there are three conditions that give us a restriction in our domain. One of them is when we have a variable in the denominator. So our domain, what we're going to start with, whatever's in the bottom, x minus 5 cannot be equal to 0 because we would be dividing by 0. You add 5 to both sides, and so we get that x cannot be equal to 5. Because if you plug a 5 here, 5 minus 5, we divide by 0. So everything else works except for 5. So if you think about a number line, here's 5, we get rid of it. We have this thing that's now split into two parts, from 5 to positive infinity, going this way, and then from 5 to negative infinity, going the other way. You have to separate them with this union symbol. Need the keypad, infinity to 5, and then union 5 to positive infinity. And then 16, again, the implied domain. So this is the one where we have an even root. I got to be careful about that. Even root is what we're focused on. So whatever's under the square root with domain has to be positive. So x minus 6 has to be greater than or equal to 0. And then you add 6, so we get x is greater than or equal to 6. And then so on the number line, you'll be looking at the number 6 and that arrowhead. Since arrow's on the left, or your variable's on the left, is pointing you this way. So 6 to infinity in a bracket. Bracket 6 to infinity. Infinity always in parentheses. So need keypad, half closed, half open, 6 to infinity. And you do know you need a bracket because of equality. It's always greater than or equal to with the even root.